Hello again. In this lesson, I am going to solve some question about the motion. Let us start with the first question. Marisa's car accelerates uniformly at a rate of 2.6 meters per second, so constant acceleration is given. How long does it take? Means we are asked the taken time. Marisa's car to accelerate speed from 24.6 meters per second to 26.8 meters per second. This is initial velocity, this is final velocity. So our formula is clear. Acceleration equal to final velocity minus initial velocity out of taken time. Final velocity is 26.8 meters per second minus 24.6 meters per second out of delta t. We are asked delta t equal to acceleration is given, which is 2.6 meters per second square. So when we make cross multiplication, delta t equal to 2.2 meters per second out of 2.6 meters per second square, so that taken time is 0.8 seconds. We can continue with the second question. Newton's accelerate his skateboard uniformly along a straight path from rest. From rest means initial velocity is 0 to 12.5 meters per second. 12.5 meters per second is final velocity in 2.5 seconds. This is the change in time. What is acceleration? Again, acceleration equal to change in velocity out of change in time. It starts from rest means initial velocity is 0, so just we write the final velocity because change in velocity equal to final velocity minus initial velocity. 12.5 meters per second out of total time is 2.5 seconds, so acceleration is 5 meters per second square. This is the A. B. What is Newton's displacement during this time interval? As you remember, there is change in time and displacement. We can use initial velocity times time plus or minus, but here it is plus 1 out of 2 at square, but initial velocity is 0. 1 out of 2 acceleration times time square equal to 1 out of 2 acceleration. We have already found 5 meters per second square times 2.5 seconds. So taken distance is 15.625 meters. Last choice. What is the Newton's average velocity during this time interval? Average speed equal to final velocity plus initial velocity out of 2. Initial velocity is 0, final velocity is 12.5 meters per second out of 2, which is 6.25 meters per second. Yes, we can continue with the third question. A robot probe drops a camera off the rim of 239 meters high of cliff on Mars, where the free fall accelerates in minus 3.7 meters per second square. If that happens in Earth, instead of 3.7, we would use 10 meters per second square. Now, find the velocity in which the camera hit the ground. As you remember, final velocity square equal to initial velocity square minus, because it moves down, make work against the acceleration, 2 times acceleration times x. Final velocity square equal to initial velocity is 0 because it drops camera, so that initial velocity is 0 minus 2 times acceleration is minus 3.7 times 239. So final velocity becomes 42.05 meter per second. We continue with the B. Find the time required for it to ground. Again, height equal to 1 out of 2 at square because it moves against the acceleration, and height is given, which is 239 meter. Then we are asked the time required. Time square equal to 2 times height out of acceleration. So time equal to square root 2 times height out of acceleration. We can continue. Time equal to 239 meter times 2 out of acceleration is 3.7 meter per second square. So answer is going to come 11.36 seconds. Yes, we can continue with the last question. There is a car traveling initially at 7 meters per second. So that initial speed is given, which is 7 meters per second. Accelerates uniformly means constant acceleration, which is 0.8 meters per second square. And distance also given. What is the velocity at the end of acceleration means when we take this distance, what is the final velocity? Final velocity square equal to initial velocity square plus, because it moves in positive direction, 2 times acceleration times taken distance. That equals to 7 square plus 2 times 0.8 times taken distance is 245 meter. So final velocity becomes 21 meter per second when we make this calculation. We can continue with B. In B it says instead of 245 meter, it takes 125 meter. What is the final velocity? Again, final velocity square equal to initial velocity square plus 2 times acceleration times displacement. Difference between the choice A is taken path, displacement. Instead of 245, we are going to write 125. Again, 7 square plus 2 times acceleration times displacement. Instead of 245, 125 meter. So in this case, final velocity is going to come out 15.77 meter per second. Last choice, again, in this time, instead of 125, we are going to write 67 meter. Final velocity equal to initial velocity square plus 2 times acceleration times taken distance equal to 7 square plus 2 times 0.8 meter per second square times 67 meter. So final velocity will come out 12.49 meter per second in this case. Yes, now we saw enough question and we finish motion unit, and this chapter has already completed. In Udemy you can follow us with new topics, with new chapters, and as we said in measurement unit, we are going to cover all IGCSE topics, and that will include IB lessons. Thank you for watching.